Hi, in this video we'll discuss about bypassing MAC address filters. First of all, what is a MAC address filter? This is a feature available for routers to limit the access of only selected clients to the router or access point. Any interface or device that connects to a network has a unique identifier called Media Access Control or MAC. So, a MAC address is used to uniquely identify a specific device. The problem with the MAC addresses is that it can easily be spoofed or changed. On this assumption, we can change our wireless adapter MAC address to make it appear like another device. The feature that the routers are offering lets you set up a list of MAC addresses that will be allowed to connect. In the same way, you can set up a list of MAC addresses that will be rejected from the access point. These are called whitelist, respectively blacklist. Let's see how to implement this in our router. First, as we can see, right now I have one client connected to the router, which is my phone. This has the MAC address of 8C38E3 and so forth. Let's copy this MAC address and use it to limit the list of devices that we will allow to connect to the access point by only my phone. This means that when we try to connect from our Kali Linux machine by using the wireless adapter, which has another MAC address than my phone's MAC address, this connection will be rejected. Many users are using this feature thinking that they are safe because no other devices are able to connect to the specific access point. They are unfortunately wrong, as the MAC address can be spoofed as we discussed earlier. The only thing that we need to obtain in order to be able to connect to the access point that only accept whitelisted MAC addresses is, you guess it, the MAC address of a whitelisted device, a device that is allowed to connect to the access point. I'm going to copy this MAC address for later use. And now let's navigate to the wireless tab. Let's first enable the wireless SID broadcast that we disabled in the previous lesson. As we discussed, this has no considerable effect on security, as the SSID can be easily discovered. So let's enable it back and let's save and apply the new settings. Next, we navigate to the MAC filter tab. Here we have the option to enable or disable MAC filtering. By enabling this, we are asked about two lists that I mentioned earlier. We can either specify MAC addresses of devices that will not be allowed to connect, or blacklist, or we can specify MAC addresses of devices that will be allowed to connect, also called whitelisted devices. We will use the second option here, as we want to be able to connect from my phone to the access point and my phone only, no other devices. So I will select Permit only clients listed to access the wireless network. The first option will prevent the listed clients to access the wireless network. And now let's click the Edit MAC Filter List button. This will display a window that allows you to enter up to 256 MAC addresses. We are going to enter just one address here, the MAC address of my phone, which I copied earlier. So I will paste that address here and we'll save and then apply the changes. And finally we'll close this window. And what I forgot to do here is to also save and apply these settings. So you will need to apply the new settings here also, something that I forgot to do in this video and realized later why this was not working. So what we achieved so far: we set up a whitelisted of MAC addresses, a list containing only one address right now, which is my phone MAC address that is allowed to connect to the access point. By using this option, we limited the access to the wireless network to only my phone and no other devices. We thought that this will increase the security of our wireless network, as no external devices will be allowed to connect to it. Great! Now let's open PuTTY, which is already connected to my Kali Linux machine, and let's put our wireless card into monitor mode, so we will be able to capture wireless traffic. Again, we can do that by typing rmon-ng start followed by the name of our wireless interface, which is WLAN 0. We can see that the monitor mode has been enabled and the new interface name is MON0. We can double check that by typing airmon-ng with no arguments this time. And indeed, the MON0 is available. Now let's display a list of available wireless networks by issuing the airondump-ng followed by our MON0 interface. This will show a list of all wireless networks available in our area. The network that we are interested in is again Wireless Lab. We can see the channel that this network is using, which is 6, and the access point MAC address. Next, I will stop the execution of this command and we'll take a closer look at this network only. We can do that by using aerodump-ng followed by -c parameter, which specifies the channel that is used by the network, in this case 6, the -a option, which ensures that only associated and connected clients will be displayed, the -BSSID, which contains our access point MAC address, and finally our monitoring interface, MON0. We can see that a client is connected to the wireless network and that client is my phone. So we have found one MAC address of a whitelisted client that is allowed to connect. If there were more clients connected, we could obtain more MAC addresses of whitelisted devices. Anyway, this information is enough for us as we were looking for a MAC address that is allowed to connect and we got one already. We have the information, but our wireless adapter has of course another MAC address, as these addresses are unique to each network device or interface. So how can we trick the access point into letting us connect to it even if we don't have a whitelisted MAC address? The solution is to spoof or temporarily modify our MAC address to make it look like the one that we just discovered and that is allowed to connect. There is a utility that lets you easily change the MAC address of an interface. Its name is MAC Changer. Now, if I type MAC Changer in my PuTTY window, I get a response that the command is not found. This utility used to be included with Kali Linux by default in previous version, but is not the case with the version I'm running. No worries though, as the utility can be easily installed by using the Kali Linux package manager called Aptitude, something that we used earlier in this course. In order to install MAC Changer, we just run apt-get install command followed by the name of our utility, which is MAC Changer. We can also specify the -y option so that Aptitude will not ask us for more confirmation before installing the utility along with its dependencies, if any. And couple of seconds later, if we try to run MAC Changer again, we can see that the utility is now available in our system. For more options, we can use the -help parameter. Before being able to change the MAC address of our wireless interface, we need to disable the interface so it will not be in use, otherwise we will not be able to change its MAC address. We can do this by typing ifconfig followed by our interface, which is WLAN 0, and the down keyword, which brings down or disables the interface. Let's now copy the MAC address of the whitelisted device that is allowed to connect, and we'll use the MAC Changer along with the -m option to change the MAC address of our wireless LAN interface. We can see the permanent MAC address for our interface, the original address that comes from the factory, the current address, which was the same as the original one, and the new address, the one that we specified after the m parameter, the one copied from our whitelisted device. So we have now successfully changed the MAC address of our WLAN 0 interface or wireless interface. Let's bring the interface back up by using the ifconfig WLAN 0 app command this time. And now let's check the MAC address of our device by issuing the ifconfig WLAN 0 command. And as we can see, our wireless interface now has the same MAC address with my phone, which was a device that was allowed to connect to the wireless network. And the final step is to try to connect to the wireless network, and we can do that by typing iwconfig WLAN 0 ESSID followed by our ESSID, which is wireless lab. Let's now try to obtain an IP from the DHCP server by using the dhclient WLAN 0 command. If the dhclient command does not execute in a few seconds and appears to hang, it means that the router will not let us connect to it. But as we now have a whitelisted MAC address that is allowed to connect, the dhclient returns in few seconds, meaning that we were able to obtain an IP address from the router. And now we are successfully connected to the access point by using a spoofed or modified MAC address. We can double check the connectivity by performing a ping request to the router's IP address, which is 192.168.1.1. As we can see, we received replies to our request, meaning that we were able to communicate with the router, and this allowed us to connect. It might happen that the router's interface will not display the DHCP clients list information correctly, as there are now two devices connected that have the same MAC address, so you might see no clients in the list as earlier, the original client, as in this case my phone, or the new client, the Kali Linux machine. Anyway, we are connected to the wireless network, and this is what matters to us. And if you really want to make sure that you are connected to the wireless router and obtained an IP address from the DHCP server running on the router, you can use the ifconfig WLAN 0 command to display the IP information about the wireless interface. We can see that 192.168.1.138 is the IP address allocated to this interface, the same as the one assigned earlier to my phone. So to recap, in order to be able to connect to a router that has MAC address filtering enabled, we will need to obtain at least one whitelisted MAC address from a device that is allowed to connect. We can obtain this information very easy by inspecting that specific wireless network along with its connected clients. Any MAC address of a connected client can be used as a whitelisted MAC address. Then we used the MAC changer utility in order to spoof or modify our wireless adapter MAC address to the one of the client that is allowed to connect. By doing that, we become a whitelisted client and we are allowed to connect to the wireless network. We demonstrated that by using a MAC address filter as a security measure is not a great idea, as these addresses can easily be spoofed and used by initially non-authorized clients to connect to the wireless network. Thanks for watching.